we've got a 2019 BMW M4 Non-Start. In this video, we're going to show you a completely new method designed by us at RMS Diagnostics to see if we can fix this car. As far as we know, we're going to be the first people to use this test procedure on this type of fault. So follow along for the ride, see if the method works, see if we can fix this car. Let's get into it. Have you ever seen a prettier car than a BMW M4? The only one I can think of is the M2. I think that's a nice, short, squatty one. You got them, Audi Quattro, early one, short little thing. They were pretty. Them and an Audi and the Audi estates. So I'm not really into cars and doing all that. I work on too many of them, but this one has come in. It's come in with a 5-volt reference fault. That's all we know so far. It's come from another garage. They've checked it out, told me the codes, said it's got this reference code and it's got 3 or 4 different fault codes listed. They've had the ECU out, they've sent it away, had it tested. Apparently it's come back fine. We all know how well that works sometimes. So we're going to get into it. I'm going to try and do something new, which I've never done, or I've spoke to a couple of people. I spoke to Darren at Mechanic Mindset and James Dillon about this while I was at Auto Mechanical last week, about how to test 5-volt reference and whether we can use an amp clamp to see which circuit is shorted. The only problem with this, I think the ECU is tucked away, so it might not be the easiest one to find. So we're going to have a go, see if this works or not. We're going to diagnose the fault anyway and work through it, and we're going to be using as much as we can off the new Think Car trolley. So yeah, we've got the scope, we've got the 399 on there, we've got test probe, we've got technical data on there. It's all in one trolley. We're going to use as much as we can on that, but I think I do need to use something of all data to explain to you what we're going to do and how we're going to do it. So let's get it scanned, find out what codes we've got in it. Let's make a plan. Right, let's give it a high-speed scan. This is how quickly it's reading every module on the car in real time. There we go. So that's read everything. If we go to report, and save that, it will come up with a full sorry about that. I had a phone call from Alex from Impact Diagnostics, who knows these inside out, and I was trying to find out how to split screen this to add the scope to it, and he interrupted my video. How rude. Anyhow, right, what have we got? So that is scanned everything we need to scan. We've done... Did I show you the report? No, we was just doing that part, weren't we? Confused me. So this is the report, so you can see everything sort of listed. So in differential lock, we got torque acceleration. In the central gateway, we got central fault memory full. So we have got accelerator pedal, charge pressure sensor, electronic wastegate, and is there something else in there? No, and 5-volt monitoring fault. Also, I don't know how much it does. We can ask Cleve. Thinking, what does it think about 5-volt reference fault? It's having a bit of a think. So I'm not sure how many scan tools have got this on it, but I don't think there's many what have got AI built into it. Well, it's coming up with saying there's a Valvetronic system fault. Motor current too high. Typically indicates an issue with the Valvetronic system. So that's not actually part of the fault code. But, well, that's what he's saying. Be interested to know whether that is got anything to do with it. But could be right, could be wrong. Anyhow, let's get rid of that. Let's go into the engine management. We're going to enter there. So we can go into it directly. So, fault codes. Let's see if we can clear any of them. Oh, it says it's tried to clear them, and they are all still there. Right, so they are right. They have got 5-volt reference fault. It looks like a few sensors and stuff have shut down. First one we're going to have a look at is accelerator, because depends if it's dead short. Sometimes they have a low voltage and it won't read it. Sometimes they're just incoherence because it's only got slightly different voltage. The throttle pedal is unbolted out of this. I think they may have tried one already. So if we go into data stream and go to accelerator position, there should be 2 reference voltages. Okay, one's at 0.37 volts and sensor voltage 1 is at 0. The accelerator position is at 0%. So let's just get in and give it a bit of a push. Okay, so accelerator voltage on the sensor 2 is going up to 2.27. The other one's not moving at all. So there we go. So we know we've got an issue on that voltage rail. There's a few different ways of checking a 5-volt sensor. One thing I will just show you, we have got Haynes Pro loaded onto this. You can split screen it while looking at your data or whatever you need to do. Body control module, did I see accelerator position sensor? Nope, that one. And it's got a diagram for the way it works. And it even gives you a way of testing. Let's just make that a little bit bigger. So it will tell you to go from earth over to pin 1. Does it measure between 0 and 0.2? Yes or no? Then you can go down to the next one. It will tell you where to test after that between the engine ECU and there. So yeah, quite a good. I've done this before on the voltage inputs to the engine ECU, where it tells you, you know, check your switch live into it, check your control to your engine control relay. Then once the engine control relay is turned on, check if you're getting it back out down to the engine ECU, things like that. So it's quite a good little system. So that is all in one tool, but we're not going to use that today because this doesn't go as in depth as the BMW diagrams, which we're going to put up on All Data. So let's show you on there what I think we're going to try and do. Okay, so a lot of cars don't actually list this like this. They will just say we've got 5 volt going down all these pins out to each unit. The BMWs do list it very well. It shows BMW sensor voltage 1 goes out, goes to Valvetronic servo motor. That's funny because we haven't got fault code in it for that, but it has got it in there. It did come up on AI for that. So, Valvetronic, electronic wastegate, position sensor, high pressure pump, boost pressure sensor, and electronic control module. They're all on one set of 5 volts. The next lot are 0 gear sensor, crankshaft sensor, intake. So we're not looking at that side of it. We've got throttle, electromotive throttle actuator, and EGR sensor on sensor voltage 3. So we know it's not these ones. It's going to be something on this line here. So 5 volt obviously comes in as 12 volt, somehow changes to 5 volt through something, resistor, transistor, something, some unit in there is doing something and putting voltage out of these. So it puts voltage out to it. Because this is running through something, you short that one out to earth completely, they all short out. Because this is something in here, it's not fused or anything like that. Because this is a resistance, this won't blow. But sometimes they'll turn off. If it sees too much drawdown, if it's a transistor or something like that, this could turn off and lose the current drawdown to it until it's either cycled, ignition cycled or anything like that. I'm not sure. But if this was shorted, one of these was shorted and we disconnected it, normally it comes straight back on. So there's a chance that whatever draw we got coming down here, if this one was shorted, or yeah, accelerator position was shorted through the bulkhead, coming out of the ECU, I would think we would get a high amp draw on an amp clamp across there. Even if we had to cycle the ignition turn it back on, and then you see it peak up and then back down because the drawer is on here, then the transistor or whatever it is shuts itself off. You might only get it for a millisecond, but if we go over all of them and then it shuts down, wakes up, shuts down, wakes up, we might be able to determine which one it is, because normally you'd go along and disconnect all these, but again on this engine it's all buried, so I'm not sure whether we're going to do it. So we might have to do it the old-fashioned way of finding which one it is, and then once we know, we'll actually go across and put it on the wire, see what drawer we got. So might work, might not. So I've spoken to James and Darren, and they're going, yeah, you know, sounds about right. So we're going to have a go at doing that. So we sort of know what area we're going in. What we're going to do first, let's check the accelerator, see what voltage we got down to that. So that is pin 5. We'll go down to there with the scope cable, and we'll see what we got on there. So let's have a look. We've got our scope connected. Let's just show you that. We're going straight onto the accelerator pedal because it's nice and easy to get to. So I'll show you what we've done. So we've got our scope connected up down here, and we've gone to pin 5, which is the one which we think we've got a short on, and we've gone to pin 3, which is the one we know we haven't got a short on. And so pin 3 is showing 5 volts. And again, on the scope, it is showing 5 volt. Pin 5 is just over 0, which is, I think it's 0.05 of a volt. So, two things are happening. Either we've lost the 5 volt from the ECU, or we've got a short. They say they've had the ECU tested, so should have mean it's okay if it was tested by a good company. I don't know who it was. So what we're going to do, we've got that done. We're going to touch the wires together, which if it's got a short on pin 5, it's going to short out pin 3 and lower the voltage down. So we will see the voltage drop as we touch them if there's a short. Doesn't mean that it's not the short inside the ECU, but it does mean if we put 5 volt to that, doesn't short and it puts 5 volts out to the other sensor. That just means we're losing the 5 volt out from the ECU. So we're going to do that quickly. I'll show you on the scope while I do it. I can see it on the meter and see if it's shorting out, and you can see it on the scope. So blue wire, touching together, yeah, drop straight down. You can see it on the meter as well. I will show you. Off, touching, 0.3 volts, and then back to 5 volt. So that does prove we got a short on that circuit. Where could be, again, could be in the inside the ECU, I don't know. So we're going to try and do that with the amps clamp to see what it's on. It's definitely on the accelerator pedal because that's actually disconnected. So we've got a few more things to do. There is a map sensor or boost pressure sensor up on the intercooler, so we can pull that off. I'm going to move that out of the way anyway, show you where the ECU is, and then we'll work out a way of working backwards to see where this 5 volt's going. So let's have a look. Okay, so intercooler, we're just pulling this off. Oh, we're a bit echoey. Just done it. It's been off before because it's got different hose clips on there. Apparently this just pops all the way up. And also we have got the boost pressure sensor, which we're going to disconnect. That'll prove one more thing. In fact, I want to pull it off anyway. Let's just see. We've just disconnected the boost sensor. Let's have a look, see if it's changed anything. And no, we've still got the 5 volt and short. So that's one other thing eliminated. Apparently, this unit will move up and fold up. Out of the way. Noisy. There we go. Up there, up there. This is about as deep into mechanical as I get. I don't like it. Right, just pull that. They've obviously lost that one and put an aftermarket one on there at some point. Right, that come off there. Yep. Okay, I've seen this done. And just fold it over, lean it out of the way. It's a water cooled or heated intercooler. Right, I'll show you. What do you think I'm going to do? Shirts anyway, eh? She's a bit flash. So, let's have a look. So, that's the ECU down there. Looking on at how to get that off, it is manifold off and then unbolt it from there, apparently. So, ideally, just get a torch. See, ideally, I'd like to go on to them plugs to test which wires going where to see which one's playing up. But I don't think it's going to be that easy. We've only got a couple more things to check, I think. If they're all on the same plug, we might be able to remove that plug, split the wire and loom, and do our checks like we'd like to do on the amps clamp. So let's go and have a quick look, see which ones we're doing. So, no, accelerator as in 2111B, the boost pressure and position sensor high pump, that's on 2B. Electrical wastegate is on 3B, and Valvetronic motor is on 4B, which is handy. Wastegate, I think, is going to be tucked away. Down, obviously, on your turbos, tucked down the side. High pressure fuel pump position sensor. That's probably manifold area. Valvetronic, that should be up the top. So I think that's the next thing to look at. So I think, again, we're going to go down a normal route and then try and test it, because if it was a normal, like a Vauxhall ECU where it's right in front of you, you could just run along it fairly easily with your amps clamp, but I don't think this one's going to be as easy. So let's find the fault and then do a workout test after that. We've got to do it that way. So let's try and get to this Valvetronic motor. Let's find out where that is. Valvetronic servo motor. That's a good thing with all data. It does give you a sort of hyperlinks like the dealers do. Some of it works, some of it doesn't. It's not perfect, but it is fairly good. What we've got here? So we've got cam unit 18 is a 12 pin plug. How does that work? Okay, got Hall effect sensors. The supply voltage for Hall effect sensors is going to be 5 volts, so that's going to be it there, which it does show it on, yeah, on that plug. So where's that going to be? Doesn't tell us. But obviously your valves, cams, it's going to be on top of the cam sort of area, cam box. So let's get that stripped out, see if we can find that part, disconnect it. If not, we're going to have to go down to the wastegate and to the high pressure pump. So let's have a look. So managed to strip off all the inlet ducts, that take the air filter housing out, etc., all that sort of side of it. So we have got all your coil packs. This is the Valvetronic unit. That's there. So what we're going to do is turn the ignition back on, watch the scope, disconnect that, and see if that makes a difference. Again, what you've got to be careful of is if this is shorted under here. Doesn't look like it has, but yeah, if you're disturbing too much all in one go, you do want to try and keep it out, try and keep it on, try and keep the scope on so you can watch it as you're going. So let's have a look. So obviously we've got the blue line up at 5 volts. This one's down shorted. And there we go, it's back. And once again, disconnect it, short, and disconnect, short, disconnect. Takes a little bit of time to come back up, but I don't know if that's just the scope refreshing or what, but there we go. So, AI was right, it was wrong. can't be the 5-volt reference thing unless the fault code, the description was wrong, and it would have, no, it would have said 5 volts. It knocked 5 volt out on all of them. But maybe it's a known fault. I don't know. So we got the fault on this one. Red wire, pin 11. So it says pin 11. Yeah, meant to be pin 11 on there. We'll just double check on that doodah. Where'd it go? 5 volt. Doesn't actually give us a pin data, but it says, I think it's red wire pin 11. So if we open that up, if we can get to that single wire, put an amps clamp on it, then we'll plug in the map sensor. We'll have the map sensor plugged in, put an amps clamp on that, then we'll have this connected up, put an amps clamp on that, and we'll see if there's a difference. See if it's going to work. Ha-ha! It works! So, let's just show you quickly. I'm getting all excited, aren't I? So, we've managed to split this apart. This is the red wire pin 11. This is your earth, pin 10. So, this is all we need. With this amps clamp set to 0, near enough. They do wonder. It's got no draw. Let's put it on there. No draw. Connect it up. 0.22 of an amp. And also, it's actually coming down the earth. This is earthing the unit, 0.28. We disconnect that, the actual earth lead into it, so it is literally shorted through there down to this earth. So back onto there, 0.24, 0.25, 0.24. Perfect. So that is showing. And then, so we'll leave that connected. That's that one. Over on the blue one, I've actually got it on here as well. Plug that in. Zero again. Literally 0.2 of an amp. 0.1. Drawing very little. If I disconnect that so the 5 volt goes back to it, draws a little bit more. 4. So that one's got, so that's connected, that's working. So it does work. It is still supplying 5 volt down to here. So over the moon. So where are we? Boost pressure on the blue with that connected, with the short gone, it still doesn't really draw much down that cable anyway, down to that sensor. It's got very little draw on it, so it's just a supply. With this one shorted, this is about 1/4 of an amp, so it's drawing. So yeah, it does work. It doesn't shut this off. It constantly draws down this one. So we go along all 5 of them wires. If they were just coming out the ECU, 5 wires, amps clamp, amps clamp, amp, you would know which one it's going to. Then you can follow that path, whether it's the wiring, a short, a chafe, or the sensor itself. But you will know it is a good way to test the system. I'm only saying this on this type of ECU. Maybe they're different, I don't know. But it doesn't shut off the supply when it sees a short. So we're going to quickly connect it up, put everything back together, and just make sure the fault codes are cleared, and then we'll make a decision what we're going to do. But that is going to be an internal part in that engine. I wouldn't even know what it does. Where is it? It's that. With the motor, maybe, no, it looks like a whole thing, doesn't it? I don't know. Yeah, not a bit of me, that's what that is. So, yeah, we've diagnosed it. Let's just confirm, let's get them fault codes cleared, and I'll show you it working. Okay, so a couple of tests we're just going to carry out before we go much further with it and put it all back together. This is how it was presented to us, with everything still connected. It's all in there. And again, we got the scope on it. That's showing 0 volts on one, and it is showing 5 volts on the second line. And the Hall effect sensor is 0 on the live data, as you can see, and 3.7 on the second sensor, like it was when it presented to us. So what I'm going to do, I'm just going to disconnect that servotronic unit, whatever it's called. Watch this come back up. If that one comes back up, we should have accelerator working again. All the fault codes should clear, apart from, obviously, that, because it's going to be disconnected. So let's do that quickly, show you that working. So, shut up. Somebody out there revving up, ruining my video. So, disconnected. As you see, the scopes come back up. They're matching voltages now. And we got 0.73 volts on the live data as well. Let's just press the throttle down. So we're back probed onto there, so the throttle is connected. And again, both of them going up and down. Lovely jubbly. So let's just go back in. So that is a good little test to have your live data and your oscilloscope set up on the same screen. You can see them both going up and down. If for any reason it was giving out a signal, but you had a bad connection down to your ECU, you would see, so if you was doing it on the other lines, the output lines, not the 5-volt feeds, if you was doing it on the output lines, you could see this going up and down while looking at the live data. If the pedal's giving out the signal, but the ECU's not receiving it, that could be where you've got a breakdown in the line back to the ECU. Let's just go back in, see what fault codes we got. I assume we're just going to have the one left for the, what's it, so got them all in there, clear DTCs, and we can just move that across slightly, make it a bit bigger. And there we go. So it has cleared all the fault codes. It hasn't actually shown the one for the Valvetronic Doodah What's It, but let's just cycle the ignition and do a rescan. And there we go. It is all cleared. It has just come out of the Valvetronic servo position sensors malfunction. Obviously, that's an internal short where it's drawing down that earth line as well as the feed. It does mean it's a dead short inside on one of the sensors, more than touching earth inside the engine, because if it was touching earth, like a short to ground of the engine, it wouldn't be drawing down the earth lead, so we know it isn't in and out. It will be the component at fault, so they're going to need to do that. So that is pretty much it. So yeah, so it's all cleared. He needs a new servo motor. Let's give him a ring, see what he says. And there we go, another one done. So yeah, hope you enjoyed the video. Hope you learnt something from the little amps clamp which we were sort of using and working out that different test process. I'm gutted that we couldn't fix it and fit that part and go on a road test. The last M series which we done got amazing views, and I don't know if it was because I took it down the road, I don't know, but you know, let's see how this one goes. I've spoke to Darren Quinn from Mechanic Mindset about this test procedure. We're going to try and record a proper training video of how to do this with some test procedures and maybe a different ECU, or maybe set up a breadboard with the process on it. So if you don't know who Mechanic Mindset is, go and check him out. There's a link in the description below. Very good technical training. If I can make a video to go on his app, it'll be amazing. So yeah, hopefully we'll get that done. So thanks very much for watching. Hope you enjoyed the video. Hope you learned something. Obviously, we did use a think card to fix most of it, apart from the wiring diagram, some old data. That was good to see which way they do come out the ECU, but I think it's because it's got multiple sensors with 5-volt references that, you know, made it a bit easier. But if you've only got 8 or 9 on an ECU, if you've got it in front of you, you could just run through it and it'll be quick and easy. So, yeah, thanks so much. We'll see you next time.